Hi everyone, and welcome to another video of the SAFI webinar series. In this video, we are going to have an overview of the integration lines command. The integration line command allows to associate a group of plates and/or members to a reference axis system called an integration line. To define the integration line, we must specify 2 points which create the axes passing at the center of the gravity of the core. At each division along this integration line, the total forces on the cutting plane are computed considering the lever arm when calculating the moments. The force distribution on each cutting plane may also be obtained. The Edit Integration Lines command can be activated using the shortcut G and allow us to edit the attributes of an integration line. There are 3 types of integration lines: slab, core, and concrete shear wall. Without further ado, let's start our demo. Before creating an integration line, we need to create a group of plates. To create a group of plates, we can use the selection command. I'm going to select all of the plates in the model, and I will use the command define selection group and specify a name for this group. I then click OK to validate. Next, to add an integration line to the model, we use the command add an integration line. It is possible to select the type of integration line before creating the integration line. Let's select the command add slab. Now, we select the starting point and the end point. The user can edit different attributes of the integration line. The name allows the user to easily refer to the integration line, and therefore, this name should be meaningful and unique in the model. The type of integration line allows to specify the type of calculations performed when integrating the plates and the internal stresses. When the core shear wall option is selected, the total forces are computed considering the effects of the eccentricities when calculating the moment. When the slab option is selected, the forces per unit width are computed without consideration for the eccentricities. The provided results are according to the option chosen. If the integration line is of the type of a concrete shear wall, a wall can be associated. If an integration line is generated automatically, the wall ID will automatically be associated. This parameter is optional. The rotation angle parameter allows to adjust the orientation of the internal axes of the integration line and its longitudinal axes in order to simplify the interpretation of the result. Next, we find the coordinates. So, we have the coordinates of the starting point and the coordinates of the end points. We can edit the coordinates directly from this menu. For example, if we want to edit the Z coordinate, we can specify here 0. If we click OK, we see an update to the coordinates. When we're modeling a slab, the user can specify if the strip is symmetric and can specify the width of the strip. For example, 5 meters. Next, we find the analysis parameters. The user can specify the thickness multiplication factor for the shear design, the number of divisions if needed, and finally the element group. We need to assign the element group to the integration line. I'm going to assign the slab group that I created, and then I will click OK to validate. Now we can see the display of the integration line, including the width of the strip, which is 5 meters in this case. To edit an integration line, we use the command edit an integration line. From this menu, we can also use the shortcut G. When we activate this command, we click on the integration line that we want to edit. More attributes can be edited for the concrete design. The user has optional parameters that can be specified, and also we can specify slab attributes in this tab. Now let's run the analysis. The results on the integration line can be displayed as an equivalent member. For example, graphically, we can display the bending moment diagram. In the same way, we can display different axial forces. The software calculates the result of the integration lines after the analysis. The user can then edit the integration line after the analysis. For example, this integration line here, we can change its position. Let's say, instead of a position of 8,000, let's use 6,000, and we click OK. Now the position has changed. The user does not need to run the analysis a second time, but instead, just update the results on the integration line using this button, Refresh the Integration Line Results. The software will recalculate the results on the integration line accordingly. The user can display specific results for the integration line depending on the type of integration line. For example, we can display the integration line forces for slabs. This command allows to view the results of any calculation point in any integration line in the model. This window is made of a table and a graph. All forces of the member and plate elements crossed by the cutting plane are summed and brought to the center of the integration line. It is important to keep in mind that the convention of the integration line results is identical to the convention of the member results. For example, the moment MZ is a moment around the Z-axis that compresses the top fiber. To delete an integration line, we can use the command delete an integration line. It is also possible to edit the integration lines using a numerical table and the command integration line. Thank you for watching, and catch you in another one of our webinar series videos.